So this is an introduction to trigonometry. And trigonometry always has to deal with right triangles. And there are a couple things that we need to talk about before jumping into these problems. So in a right triangle, there's the right angle. There are two acute angles. So we call this one A and this one B. There are three sides to any triangle, obviously. The side opposite of the right triangle is always the hypotenuse. So there's the hypotenuse, and the other sides depends on which angle you're looking at, tells you what the name of that side is. Let's start that over. The names of the other sides are determined by which angle you're looking at. So if I'm looking at angle A, the side opposite of angle A would be over there. So this would be opposite for A. And then the side that's touching A but not the hypotenuse, because the hypotenuse obviously touches A, the other side is the adjacent. Okay, you can flip this around and think about it from B's perspective. So if I redraw this, angle B is up there. The hypotenuse is still across from the right angle. So the hypotenuse is always in the same spot. So this is the hypotenuse again. And then opposite the B is over here. And then adjacent to the B is on the left side. So the adjacent and the opposite switch sides depending on which angle you're looking at. Those names are important because we need to be able to talk about the sides, and we need to be on the same page because there are three different ratios for these right triangles. The first one is called the sine, and the second one is the cosine, and the third is the tangent. There are actually three more that you might learn later in pre-calc, but for now, these are all we're going to talk about. Each one has an abbreviation. They just use the first three letters. So we have sine, S-I-N, cosine, C-O-S, and tangent is T-A-N. Each of these functions has a ratio based on the opposites, the adjacents, and the hypotenuse. For sine, it's the opposite over the hypotenuse. I'm just going to abbreviate those. For cosine, it's the adjacent over the hypotenuse. And for the tangent, it's the opposite over the adjacent. Okay, the best way that I have found to remember that is a quick little thing called, that's, I say Soh Cah Toa. So, S-O-H, Cah, C-A-H, and Toa, T-O-A. So those letters come from the little equations up here. So the sine equals opposite over hypotenuse, that's S-O-H. So that's so, and then the cosine equals cosine over, so cosine equals adjacent over hypotenuse, so that's C-A-H. That's the Cah, and then the tangent equals the opposite over the adjacent, that's the Toa, T-O-A. So that little phrase right there is going to help you remember how to solve these. So if we go look at number one, I'm going to write the Soh Cah Toa up here. Soh Cah Toa. So if you spell that right, then usually you'll get the questions right. So that's angle that's marked 64. Okay. The first thing you do is label the pieces. So the 25 is across from the right angle, so he's the hypotenuse. So So that's the hypotenuse, and then the x is across from the 64, so that's the opposite. And the adjacent would be this one. So we know the hypotenuse, and we are looking for the opposite. So you use the one of these three that has those two pieces. So the opposite is the O, and the H is the hypotenuse is the H. So we're looking at sine. We're looking at the SOH. So the sine equals the opposite over the hypotenuse. So the sine equals the opposite over the hypotenuse. That's the little equation, the little formula that you're plugging things into. And really, I should probably have a letter there, because that's where you're going to put the angle. Okay, so I'm going to plug in the angle in the sine function. So sine of 64 equals opposite is x over hypotenuse is 25. And once I've got that formula, that equation written, all I do from here is solve for x. Okay, so I want to solve this for x, so I'm going to cancel out that 25. So I'm going to multiply by 25 on both sides. And that cancels the 25s over here, so leaves x equals 25 times the sine of 64. And once you get here, you just grab your calculator and use that. So you need to make sure that it's in degree mode. So on the TI-84, you turn it on, and there's a mode button right beside the second button up in the top left. You hit the mode button, and then the third line down says radian and degree. So you want the degree word to be highlighted, so you go over and hit the degree. Go over and select the degree by pushing enter on it, and then you can just hit the clear button and you'll go back. And then you just type 25, and you can hit times the sine, and the sine button is SIN. It's two buttons above the 7. And then you type your angle, which is in this case 64, close off the parentheses, and hit equals. You should get, for x, you should get 22.4698516, but it says to round to the nearest tenth, so we're just going to leave it at 22.5. So there is the x value that we were looking for. Okay, number 2 is very much the same. You first label what your pieces are. So the hypotenuse is side across from the right angle. Then we're looking at the 47-degree angle over here. The 12 is attached to it, so that's the adjacent. And the x is across from it, so that's the opposite. So I know the adjacent, and I'm looking for the opposite. So we'll go back to looking at your Soh Cah Toa. The adjacent and the opposite, that's used by the tangent. So the tangent equals opposite over adjacent. So now you just plug in what you know. We know the 47-degree angle, so we have tangent of 47 equals, the opposite is x, the adjacent is the 12. So we just solve for x by multiplying both sides by 12. Once you get the hang of this, it gets pretty easy. So we have 12 tangent 47 equals x, and grab your calculator, type it in. So we have 12 tangent 47. Go in the calculator, close off the parenthesis. So x equals 12.86. So I'm going to change that 8 to a 9. So 12.9. Okay, do this number 3 here. So I've got this 18-degree angle up there. The hypotenuse is right there, and the adjacent is the x. Okay, the opposite's the one that we don't need to worry about. So go back and look at your Soh Cah Toa. The adjacent and the hypotenuse are the two pieces that we are interested in. So use the cosine, because it's got the a and the h. So we have cosine equals adjacent over hypotenuse. So we put cosine of the angle, 18, equals the adjacent is x, over the hypotenuse is 34. So we just multiply by that 34. And we have 34 cosine 18 equals x, and then just type it in the calculator. 34 cosine 18 gives us 30.33, so just leave it 32.3. Okay, I'll do this number 4 here with you, and then let you finish the rest. So I need to label things. There's my hypotenuse across from the 35, so that's the 9 is the opposite. The x is touching the 35, so that's the adjacent. And then I know the opposite, and I want to know the adjacent, so that's going to be tangent, because I have TOA, T-O-A. So the tangent of 35 equals the opposite over the adjacent. So when your x is in the bottom, you have to multiply by the x to get it out of the denominator. So multiply both sides by x. I'm just going to leave x tangent 35 equals 9. Okay, so this x tangent is x times tangent, so we just have to divide by the tangent 35. Tangent 35 would just be a number. So I can divide by any number. So that's going to cancel that. And x equals, now I grab the calculator and just type in 9 divided by tangent 35. And I've got my answer. So this looks like 12.85, so it's going to be 12.9. And there we go. So if x is in the bottom, that's what you do. You just multiply by it and then divide by the tangent or the cosine. Okay, I'll do another video that shows you how to find the angle measures.